subtopic number 4, which is on properties of waves. So these are the learning outcomes. It's just really long for me to read it for you. So make sure you understand what do we need from this subtopic. What do you need to understand for this subtopic? So first, kita ada satu wave where we call it mechanical wave. So what is this mechanical wave? Mechanical wave is defined as disturbance that travels through particles of the medium. Typo. Travels through particles of the medium to transfer the energy. So the transfer of energy untuk mechanical waves happens through a medium. So there are two types of waves that is based on the transfer of energy. The first one is progressive waves. Second one is standing waves. So marilah kita tengok the first one, which is progressive wave. Ni salah satu contoh disturbance. Kalau kami kita gerak-gerakan, there ada transfer of energy in this spring. Okay, so progressive wave is defined as a wave that propagated continuously outward from a source of disturbance. Ini adalah satu contoh source of disturbance. So the particle oscillates around their equilibrium position, tapi they do not travel. So they oscillate saja. They go up and down, and then yang transfer tu is the energy. So the continuous repetitive disturbance gives rise to what we call a continuous propagation of energy. So that is what we call wave motion. Okay, so this is what you need to know here is progressive wave. Macam nak cakap apa? Dah pala kan? Yang inilah yang kamu perlu tahu. Okay, so it is a wave that propagated continuously from a source of disturbance. Lepas tu, they do not travel. The particle do not travel. The particle oscillates saja around the equilibrium position. And then we have a term that we call wave motion, which is due to the continuous propagation of energy lah, caused by the repetitive disturbance. Okay, macam tu lah. Now, this is a diagram that explains some of the things that you need to know lah in a wave punya motion. So we have a wave number which is K. Ingat kita ada banyak K sekarang ni. Kita ada apa lagi K hari tu pula. K tadi is the spring constant, tapi di sini K dia adalah wave number. So K ni adalah defined as the number of waves or cycle per unit distance. So formula untuk unit untuk K is per meter tu kalau nak silap. Per unit distance. Ya, betul. So, now kita perlu consider. Okay. So, untuk the top bit of this wave motion, this is what we call crest. Okay. And then the bottom one, yang di bawah ni kita panggil trough. And then this one, this from here to here is what we call lambda. Lambda is wavelength. Okay, so wavelength ni apa? Dia adalah the distance between successive crests ataupun trough of waves. Okay, so dari sini pun macam ni pun wavelength jugalah. So basically lambda ni adalah the distance for one complete wave cycle. Dia mesti complete. Dia tidak boleh dari sini pergi sini. No, it is not complete. Dia mesti dari atas sampai bawah pergi atas balik. So this is one complete wave cycle. So ini adalah your displacement. Y ini adalah your distance. Ke sini ni adalah distance. So this is your amplitude. Dari sini pun amplitude juga. Equilibrium position is your line yang di sini. Okay? Okay. Now we have to learn about equation of progressive waves. So ini adalah the equation for progressive waves. So Y ni apa? Y adalah the displacement of the particle from its equilibrium position. X adalah the distance of particle from the origin ataupun from the disturbance. So ni adalah kita punya X. Kita punya Y dia measure dari equilibrium position. Dia pergi sini kah, dia pergi sini kah. Okay, tapi dia dari equilibrium position. Next we have A. You know that it is the amplitude of the wave. K is the wave number. Omega is the angular frequency. So, equation ni, it can either have positive ataupun negative di sini. Apa maksud dia adalah it is telling us the direction of propagation. So if it is equal to a sine omega t plus kx, it is telling us that the wave is propagating to the left. Okay, so it propagates to the left kalau dia positive. Kalau dia propagates to the right, it will be negative. Okay, itu yang kamu perlu ingat. Other forms of equation adalah ini dia convert dia dari sini. Omega tu equal to 2 pi over t. Lepas tu dia kasih turun lah t tu. Jadilah t over period. Time over period. Plus minus x over omega. K, yang ini k is equal to something. Saya lupa sudah. Nanti ada kali. Kejap pa. Let me double check lah. Sekarang juga saya check. Lupa sudah ba? Aduh. Wave number. Wave number is equal to 1 over lambda. So, k is equal to 1 over lambda dia bilang. Yeah. Okay. Ito pala. Nantilah to explain yang ini. Okay. Tapi these are some of the alternative forms. Apa yang dorang buat ni basically dorang just change somewhere here k dengan omega tu lah dapat equation macam ni. Okay, v ni pun sama. Alright, okay, now kita perlu understand about particle vibrational velocity and wave propagation velocity. Saya harap kamu dapat paham saya punya tulisan tangan. Okay, so these two are two different things. Kamu perlu make sure kamu baca tu soalan betul-betul sebab sometimes they would ask you either the wave propagation velocity ataupun the particle vibrational velocity. Okay, so sekarang ni the velocity of the wave is propagating to the right. So this is what the sentence meant when the particle oscillates. Okay, dia turun terus dia at this point dia akan naik. Yalah. Tapi itu adalah the velocity of the particle on the string. On the string, this is the velocity of the particle. This turning point here, the particle would have 0 velocity. This idea is macam yang the one yang at maximum height tu. At maximum height, velocity is equal to 0. Okay, so at maximum amplitude, the particle velocity is 0. Okay, so at 0 displacement, which is at this point here, the velocity is at a maximum. And then ni pun lukisan lain je. Okay, so particle vibrational velocity ni adalah the velocity of a particle which oscillate around the equilibrium position. So velocity which oscillate about the equilibrium position. Okay, so formula dia is the one shown here. So this is the formula dia untuk particle vibrational velocity. Untuk wave propagation velocity, wave velocity ni adalah the velocity at which the wave crest ataupun other part of the waveform move forward. Okay, dia bergerak ke depan. So, wave velocity ni adalah the distance traveled by the wave profile per unit time. So, notice that a trough travels a distance of 1 wavelength. Ni, a trough. Yang dari sini ni adalah 1 wavelength. Okay, in a time equal to 1 period. So, 1 wavelength ni adalah 1 period lah. So, formula untuk wave propagation velocity ni is the one shown here. Okay, so ini adalah the formula for wave propagation velocity. So, the wave velocity ni kamu perlu tahu dia adalah constant lah. So, wave velocity is constant across the wave motion. Okay, itu saja untuk particle vibrational velocity and wave propagation velocity. Okay. Next, we have to see about displacement graphs of the wave. So we have a graph of displacement against time dengan displacement against distance. So the displacement against time graph ni, it shows the displacement of any one particle in the waves at any particular distance from the origin. Kalau graph of displacement against distance, it shows the displacement of all particles in the waves at any particular time. So this is an example, displacement against time graph. So from this graph, kalau kamu dapat graph displacement against time, kamu boleh cari amplitude dengan period. Kalau graph tu displacement against distance, kamu just boleh cari amplitude and wavelength. So period tu tidak boleh carilah. Okay, kamu tengok the difference is this two part here. Okay. Okay. Alright, so that is the theory part for 7.4. Example number 7. A sinusoidal wave traveling in the positive direction, which is to the right, has an amplitude of 15 centimeter, a wavelength of 10 centimeter, and a frequency of 20 hertz. So at t is equal to 0 seconds, a particle at x is equal to 0 has a displacement of 15 centimeter. So we have to write an expression for the wave function. Determine the speed and acceleration at 0.5 seconds for the particle on the wave located at x equal to 5 centimeter. Okay. So before that, I have to add a few stuff on here. K equal to 1 konon. Salah ba? K is equal to 2 pi over. I'll add here lah nanti. Tidak tahu kenapa saya tidak tambah tu. So K is equal to 2 pi over lambda lah. Itu dia punya formula untuk wave number. Okay, now we continue. So sekarang ni kita perlu create an expression for the wave function. So kita tahu kita ada the general equation is equal to y x t equal to a sin omega t plus minus kx. Tapi soalan cakap dia travelling to the right. So bila dia travelling to the right, kita punya sini akan jadi positif lah. Positif. Mana tu? Di sini. Travelling to the travelling to the right, negative pula. Sorry. Salah pa pula. Nanti kamu akan dapat negatif lah sepatutnya. Okay, so sekarang ni kita determine dulu amplitude, angular frequency dengan wave number. So amplitude is given, which is 15 cm. So kita mau guna centimeter lah kan. Okay, 15 cm. Lepas tu T tu memang bayar. Omega is equal to 2 pi F. Kenapa 2 pi F? Sebab dia bagi kita frekuensi di sini. So, kamu gunalah formula yang ada frekuensi. So, kamu akan dapat 40 pi radian per second. And then, miring juga ni. And then we have the wave number, which is equal to 2 pi over lambda. So, this one kita akan dapat 2 pi over 10. Sebab kita mau centimeter kan. So, dapat 0.2 pi per centimeter as the wave number. So, dapat semua ni kita bolehlah just substitute into the general equation. So, y x t is equal to 15 sin 40 pi t minus 0.2 pi x. Jangan lupa tambah where y is in centimeter. Y and x lupa pula. Is in centimeter. Y and x in centimeter. Apa ya lah, tulis je lah macam T in seconds. Okay, yang penting itu mesti ada. Bagi tahu unit dia apa. Okay. Okay, next we have to determine the speed and acceleration. Alamak, panjang pula yang ni. Sorry lah, setiap perasaan pula panjang solution dia nanti. So, yang ini kita perlu cari speed and acceleration at t equal to 0.5 seconds and at x equal to 5 cm. Okay. So, untuk yang ini, kita punya equation tadi kita tulis balik dulu. Is equal to 15 sin 40 pi minus minus K dia tadi berapa satu? 0.2 pi kah? 0.2 pi X. Kan 0.2 pi X. Ya. Yeah. Okay, so ini adalah kita punya general equation. So whenever the question asks you to determine for the speed and acceleration, kamu perlu ingat, kamu perlu derivation lah. So the derivation for this one is with respect to time. So kamu tulis balik lah, sin t minus 0.2 pi x. Okay, so the difference here is kita perlu consider time. Bila ada t saja. Yalah, with respect to t, so kita fokus yang ada t. Yang ini tidak included lah kiranya. Okay? Okay. So derive with respect to time, kita akan dapat bawa pergi depan. So 40 pi darab 15. Derive sin, dapat cos sin. So that is 40 pi t minus 0.2 pi x. Kamu masih ingat ba? Ni kan derivation. You should, everybody. I cannot explain it to you. So velocity is, ini cara dia lah. Cara dia kalau derivation, kamu bawa pergi depan. And then kalau trigo, dia tukar ini je. Cos. Sin pergi cos. Kalau cos, dia pergi negatif sin. Darab 15, so 600. So this is 600 pi cos 40 pi t minus 0.2 pi x. So itu adalah your velocity punya equation. Tapi kamu perlu ingat, kamu letak where v is in centimeter x pun kan. Belum lagi ba? Centimeter per second. X is in centimeter. T is in seconds. Okay. Lepas tu dia suruh kita apa ni? Dia suruh kita determine lah berapa. Okay. Kalau kita mau determine ni, kita substitute T equal to 0.5 seconds. 0.5 kah? Yeah. And X is equal to 5 cm. Sebab kita guna centimeter di sini, kita tiap payah convert ni pergi meter lah. Nanti tidak tally pula, tidak ngam unit. So, into V. So, V is equal to 600 pi cos 40 pi, T is 0.5, minus 0.2 pi X is 5 cm. Okay, so dapatlah the speed of the particle to be equal to negative 600 pi centimeter per second. Okay, panjang ni. Okay, next kita perlu consider for the acceleration pula. So acceleration is just the derivation of the velocity punya equation lah. Pi t minus x. Okay, derive that velocity punya equation. So 40 pi apa? 2. And then 600 pi. Sebab the derivation for cosine is negative sign, kita ada negative lah di depan. So, dapat jadi sin minus 0.2 pi x. So, kamu akan dapat formula dia equal to negative 24,000 pi square sin 40 pi t minus 0.2 pi x. Okay. So, jangan lagi lupa tulis where acceleration is in centimeter per second square, x is in centimeter, t is in seconds, c is in seconds. Okay, so lepas tu kita substitute lah berapa nilai xt tadi tu. 24,000 pi square sine 40 pi 0.5 minus 0.2 pi x is equal to 5 cm tadi. Okay, so dapatlah acceleration untuk that particular time and distance to be equal to 0 cm per second square. Penat-penat kita buat 0 pula jawapannya. Okay, panjangkan solution untuk this subtopic memang nih, biasalah nih. Okay, so that is on subtopic number 4.